All right, so synthetic division. So section 3.2. So synthetic division is another way to divide polynomials, okay? So, for example, this is a fancy word for division algorithm. So basically, this is a fancy word for saying divide. Is let f of x and g of x be polynomials with g of x of lesser degree than f of x. And g of x has a degree of 1 or more when it comes to, again, don't worry about that, just looking at what exists, but what we care about is, then there exists a unique polynomial q of x and r of x such that you can rewrite them as this. Okay, now you figure what in the world does that actually mean? Okay, so this is a simple example. Okay, so let's suppose we want to divide 5 into, let's say, 21. Okay, right the old-fashioned way. So, what times 5 gives you close to 20? That's going to be 4, right? Then you subtract, you have a remainder of 1. Okay. So what this is saying is I can rewrite as 21 using all of these numbers. Okay, so I can write 21 as 5 times 4 plus 1. And that's where these functions come into play. So notice the g of x is what we were dividing to begin with. This is the f of x function. So this is f of x. This is g of x. And this q of x is the quotient. So what was our number on the top? That's the q of x. And the remainder is called r of x. Okay, so that's what those numbers represent. So, if you go back into just, a little bit of, I don't know when we did this, well, back in the day, right? When you divide, you can essentially rewrite the number on the inside based off those 3 numbers, okay? That's what they're talking about when it comes to function now. So now we're gonna figure out, okay, what are the 3 functions that when we divide, break this up accordingly, okay? That's what's happening here, okay? Now, when it comes to long division, so right, this is long division. Again, using long division when it comes to polynomials is a pain. I know you guys are gonna hate it. I don't know if you guys have seen it now. If we actually have to do it, we will do it. But in most cases, we're going to be doing something called synthetic division because, we're going to be learning that itself. However, when it comes to synthetic division, this we can only use this if we divide by x minus c. So it's x minus c or x plus c, one or the other. Okay, so meaning there's no number in front of the x. Okay, that's the only way this new type of division is going to help out or be done when it comes to it. Okay. Now, how we're going to do synthetic division is pretty simple. Is we're going to make a little box. Okay, and the number here is always going to be the opposite symbol here. So it's just going to be opposite to that c value here. So if it's negative c, it's going to be plus. If it's plus c, it's going to be minus, right? And vice versa. Okay. And then next up, we're going to put little lines here. Okay, and you're going to put the numbers here that correspond to the coefficient in front of the quadratic. So for example, let's suppose I had this, for instance. So the numbers that are going to come here are the coefficients in front of the variables. So meaning the 5, the 3, the -2, the -1, and the 1. So you just slowly just break down 5, 3, -2, -1, and 1 accordingly. And you always go from highest power to lowest power in that order. Okay. So no variables, it's the numbers in front of the variables. That's what you plug in here. Okay. Next up is you're going to make another line, and you're always going to bring down the very first number you see there. So in this case, that's at the 5. Okay. And now what you want to do is you're going to multiply whatever's in the box times this and put it right here. Okay. And then once you do that, you're going to add straight down, get that new number, and then rinse and repeat. Multiply, put it there, add, and repeat. Multiply, put it here, add, and keep until you get to the final one there. And your final number is always going to be your remainder. That's your r of x value there. So just like over here, the r of x value was 1 because that's the remainder once we divide itself. Okay. So I know it may look a little complicated, but it's actually not that bad. Let's try an example so you can see how it would work out accordingly. Okay. So lots of examples, lots of practice here. So let's use synthetic division to perform this operation. Okay. So first off, we want to find the C value. Okay. So since it's x plus 2, opposite sign would be minus 2. Okay. So in our box, it's going to be minus 2. Now, how many lines do we have? Well, how many variables we have? 3, 2, 1, 0. So 1, 2, 3, 4. So we're going to have 4 numbers. First number is 1, 7, 13, and 6, right? Just the numbers in front of the variables. Make our line and always bring the first one down. So that's when I just bring it first down. And now we're going to multiply 1 times negative 2. And that gives you this negative 2, right? And now finally, you're just going to add straight down. So 7 plus negative 2 gives you positive 5. And now rinse and repeat. 5 times negative 2, negative 10. Add straight down. That gives you 3. Next, negative 2 times 3 is negative 6. Add straight down, that gives you 0, meaning we have no remainder when it comes to it. Okay. All right. Now, the last thing is, well, like over here, right, we knew it was 4 because when it came to it, but what is our quotient? What's the q of x value? Okay. Now, this is the cool thing. You always start with 1 degree less than you started with. So we started with 3. Therefore, this one's going to start with x squared and just go down the list. So it'll be x squared, x, and then no x's. So your answer is x squared plus 5x plus 3 with no remainder. So this is your answer there. Any questions on our first example at all?
When will we or will we not replicate the power? So x cubed is not there due to it just being factored out?
Oh, that goes, I think I give you the number part C does that. So just the next 2 examples, I think answers your question.
Okay.
Yeah. So just any questions so far just on the process. We'll get into like the nits and grits in a little bit. Good. Okay, so let's try another one. So same process, we're dividing. So C in this case, again, is going to be minus 3 because it's opposite there. All right, so it's going to be negative 3 in our box. So right, 4, 3, 2, 1, 0. So we have a total of 5 numbers. So 1, 5, 4, negative 3, and positive 9. Right? Okay, always bring down the first one. And now, just like last time, we multiply. So negative 3 times negative 1 is negative 3. Add down gives you 2. And just repeat. So negative 3 times 2 is negative 6. Add down gives you negative 2. Negative 3 times negative 2 gives you positive 6. Add down gives you positive 3. And again, multiplying gives you negative 9. And again, 0 remainder. Right? So therefore, right, since we started with 4, it's going to go 3, 2, 1, 0 x's. Always 1 less than we started with. So the 1x to the third plus 2x squared minus 2x plus 3, right? No x's. And there you go. So again, this will be your answer there. So far, so good. Okay. All right, so C is a little different when it comes to it, but let's do the same process. So C is going to be negative 1. Okay. Now notice this was 4, 3, 2, no x's, and then 0 x's, right? So notice it skips, like this one had the x's there, this one skipped, okay? However, when it comes to writing these numbers down, you have to equate for that. So what I mean by that, it should be 4, 3, 2, 1, 0 x's. So 4, 3, 2, 1, 0 x's. So we have 4 of them. That's a negative 11. 3 is negative 2. 2 is negative 8. But since we have 0 x's, I'm literally going to put 0 because I have no x's. So I'm skipping it and then minus 4. Okay, so that's the one thing you got to be very careful when it comes to the synthetic division. Every power must be associated to a value here. So if you have none of a particular one, you put literally 0 because you have 0 of them. And then from here, you just go on like we did before. So bring on the first number and then multiply. So that's 11. Add down. That gives you 9. Multiplying gives you negative 9. Add down gives you, I think, negative 17. Yeah. Multiplying gives you positive 17. Add down. And again, negative 17. And now this gives you negative 21. So this, we have a remainder. So the question becomes, how now do I write remainder, right? But again, let's just write first what we know, right? So we started to the fourth, so it's going to be 3, 2, 1, 0. Right, so just doing that. So now, how do we write the remainder? And the way you're going to write the remainder is going to be plus the number we have, 21, negative 21, over what do we divide by to begin with? X plus 1. So this is how you're going to write your remainder all the time. It's whatever number you have divided by what we started to divide by. So this whole thing would be your answer there. Did that answer your question? I hope. Okay. So again, right, if you're missing an X or any of them, right, it could be 4, you could skip 3, and you have to put 0 3s and so forth, but everything has to be associated when it comes to that. Okay, there's more practice, right, when it comes to it. So C is again negative 1. So we have 3, 2, 1, 0, so none of them are skipped. And we just repeat. So this is a 2, multiplying gives you negative 2, add down gives you negative 1, multiplying gives you positive 1, add down gives you 2, multiplying gives you minus 2, and then add down gives you again there. So again, we have a remainder. Okay. So therefore, we started with third, so we start with x squared. So we 2x squared minus x plus 2, and then our remainder, again, divide what we started with, just like that. Questions so far? Everybody comfortable? Much easier than long division. If you guys know what long division is, it's a horrible, horrible mess when it comes to it. So it makes a lot of work go away. Okay. All right, so let's just finish these up. So this one, now C is going to be positive 2, right? Opposite sign. So we have negative 1, 1, 3, and negative 2. Always bring down the first one. 2 times negative 1 is negative 2. Add down gives you negative 1. Multiplying gives you again negative 2. Add down now gives you positive 1. Add again, multiply. And now again, we have no remainder, which is nice, right? So it's going to look like the first two with no remainder. All right, so we started with to the third. So we start with x squared. And no remainder, so that is our final answer. All good so far? Okay, let's try the last one here. So it's going to be positive 4 this time. So 1, 6, 9, 3, and negative 3. All of them are there, so we don't have to skip any. And let's keep going. So this could be 10, 40. It's going to be really big numbers. So we have to take out a calculator for this one. So, the numbers are big, but it's the same process, right? We start with the fourth, so we start with 3. So x to the third plus 10x squared plus 49x plus 199, and then plus our remainder, 781 over what did we divide by? And there we go. And that's it. Questions there at all? No? Is everybody good? Okay. Let's do this one. So, just in case, let's see if you guys are actually good. Go ahead and try this one out. Give you guys another minute to finish up. see. All right, so the C value is going to be positive 2. So it's 3x the third. We don't have any x squared, so that's 0. And then negative 1 x's, and then plus 8. So this is a 3, 6, 6, 12, and that's going to be 11. And this would be 22, and that's going to be 30. So we start with the third, so 3x squared plus 6x plus 11 plus our remainder. Good job, guys. So any questions on synthetic division at all? So we're going to be using this, this technique a lot, definitely tomorrow, for sure, tomorrow. Is everybody comfortable?
I have a question on the example before this one.
Mm-hmm.
So I got 199, and then you do times 4,
Mm-hmm.
and then isn't it 796?
Oh yeah, you're right. 796, yeah. 796. Okay, so yeah, just change it. So this is going to be 793. Sorry, yeah. There you go. Good catch. Any other questions, comments at all? Good. Okay, so that's the first major part of this section, is just knowing synthetic division. Now, sometimes, however, what we really care about is the remainder. So in other words, okay, I don't, I'm happy you get to do this, but what I care about is what's the actual remainder. I mean, is it 0? Is, what's the number? Is it -10? What's the actual number itself? And you could say, okay, that's not too bad much work to find the remainder. But, in math, math people are pretty lazy. So we always want to develop ways that makes things faster and, less tedious itself. And that's what something's called a remainder theorem. So what the remainder theorem says is if f of x is divided by x minus k, or in this case, x minus c like we've done so far, then the remainder is equal to f of k, meaning you just have to plug in the value and you got the remainder. That's it. So let's see if this actually works out, because this could be a pretty interesting concept, right, when it comes to it. So what we're going to do is two different ways. The first way we're going to do this is we're going to do synthetic division to figure out what the actual value is going to be. Okay. So first, using synthetic division, we figure out what's our remainder, and see, do we always have to do that, or can we actually use this remainder stuff to make it work? So let's figure it out. So if k equals -5, that's the c value. So it's going to be 1, 4, and -5. Right when it comes to it. And just, just like we've done so far, so multiply, add straight down, and then multiply, that gives me 0. So our remainder is 0, right, when we divide. Okay. Let's see if we get the same thing if we use this theorem we have here. It says, all I have to do is plug in -5 into here, and we should get the same thing as a remainder. Okay, so we got 0. Let's see if this actually does work out. Okay, so let's just plug in -5. Well, that gives us +25. This gives us -20, and this is -5. So yeah, it does actually work out. We actually get 0. That's pretty interesting, right? So now there's two ways to find the remainder. We can use synthetic division, or we could just plug in the value to see what we get. And again, in most cases, all we care about is just the remainder, and you'll see why, in a later tomorrow actually when it comes to it. But as of now, that's a pretty interesting concept altogether. So that's what we're going to be using for the next couple examples. Just being able comfortable to find the remainder. So whenever I ask you to, in your quiz, hint, and for your homework, find the remainder of this when k equals this or c equals that. All you have to do is plug it in. But again, if you want, you're more than happy to do synthetic division if you're not comfortable doing this concept. Both will give you the same answer either way. Okay. So let's try this out just for practice sake. Okay. So let's find the remainder when k equals -3. So we're just going to plug in -3. All right, so -3 to the third power gives you -27. This is +9 times 2 is 18. Negative makes positive, and that's +6. And now we just add, subtract accordingly. So -27 plus 18 plus 3 plus 6 gives us 0. So our remainder is 0. All right, go to C. So if it's 1, again, just plug it in and see what we get. So this one's not too bad because 1 is always a nice number to deal with. So this is just 2, 9, 16, and 12. And now we just add across, right? So 2 plus 9 minus 16 plus 12 is 7. So our remainder will be 7 if we divide. Right, and last one, fractions. Everybody's favorite, right, when it comes to it. So plug it in. Now again, you could just put it as a decimal. It really doesn't matter. You're going to get the same answer either way. But even with the fractions aren't too difficult when it comes to it. So here, maybe 16 over 2 to the 4th, which gives you what? 2 to the 4th, is that 16? Yeah, exactly 16. Plus 3, 2 squared is 4, minus 2. So this ends up being 1 plus 3/4 minus 2. That and that gives you -1. And this, again, either way you want it, will give you -1/4 at the end. Or if you want -0.25, you put it in decimal when it comes to it. So either one is fine. Like I said, you get the same answer, just look different. So fractions are also nothing to worry about. All right, so any questions on the remainder theorem? So when you're just asked to find the remainder, again, 2 different ways, right? You could just plug it in now according to this theorem, or you could just use synthetic division and figure out what the last number is, right? So you just care about the remainder itself. So everybody comfortable? Yep, okay, all right. Okay, all right, so that's it for today. So we actually, before 3 o'clock, so a pretty quick lecture, since you guys look like